When factoring a binomial, the first thing that you want to do is check to see if there's a greatest common factor. And in this case, there's not. Between 9 and 4, there would be nothing in common. So same thing, I'm going to do that first, last, and middle. For a binomial, there is a first term, that 9x squared. There's the last term of -4, and there's no middle term. So we're going to call our middle term 0. 9x squared times -4 is -36x squared. Because this is negative, one number is negative and one is positive. For 36, I'm going to do a -6x times positive 6x. Positive 6 times -6 gives me -36. -6 plus 6 gives me 0. Okay, now I need to fill in my factors of 9 and -4 to get -6 and then 6. So I'm going to do 3x times -2 and 3x times +2. If I circle my diagonals here, I'm going to get 3x minus 2 and 3x plus 2. Anytime you have a binomial, meaning two terms, and both of those terms are perfect squares, you end up getting their squares separated. So our rule here says that if we had a squared plus, a squared minus b squared, that will equal a plus b times a minus b. Now let's look at a binomial that we're adding. Okay, so we've got 4x squared plus 1. Again, they're both perfect squares, but let's see what we get here. So first, last, and then our middle. My first term is 4x squared, my last term is 1, and my middle is 0. 4x squared times 1 is 4x squared. Since this is positive, it's either going to be both positive or both negative. Well, there's nothing that ends up working out that multiplies to give me 4 and adds to give me 0. So because of that, we're going to say that this is prime, or you can say not factorable.